IGCSmart, linear inequalities. So, in year 9, you would have studied just linear equations. So, say how to solve an equation like 2x plus 1 is equal to 0. This is year 9 level math. But in IGCSE and starting year 10, you'll be starting to learn how to solve inequalities. The first topic would be linear inequalities, next topic would be quadratic inequalities, and that's where you end with inequalities. So today we'll be talking about linear. In next video we will be talking about quadratic inequalities, which are a bit more interesting than linear. So let's begin. If you remember from year 9 or from previous experience with math, any linear equation can be written down in the form of mx plus k, where m is commonly known as the gradient and k is commonly known as the y-intercept. I go over this with my students a lot, way more than I really should. Now, in linear inequalities, what you get is you get a linear equation larger than something else. So let's call this E. So this is how we will be writing down the linear inequalities. And it doesn't have to be larger. So it can be smaller, larger or equal to, smaller or equal to, not equal. All of these are types of inequalities. Okay. First, let's solve a linear inequality. So let's go. 2x plus 1 is larger than 3. How do you solve that? Well, you solve it very similarly to how you would solve a just a linear equation like this. So let's imagine that this is an equal sign. What would you do? Well, obviously you would carry the 1 over there, or you would subtract 1 from both sides. That's the same thing. So let's do the same here. You get 2x is larger than 2. Okay. What's the next step? Well, the next step is pretty obvious. You have to divide everything by 2. And that is what we're going to do. And we will get x is larger than 1. And this is it. This is where our linear inequality ends. And this is the solution. It's a pretty straightforward topic. And yep. So, but let's go on to something slightly harder that many students get caught out on. So let's solve the linear inequality negative 2x plus 1 is larger than 3. Very similar to the one that we just solved, but with the negative 2 being the gradient. So once again, you subtract 1 from both sides, you get negative 2x is larger than 2. But now what you have to do is you have to divide it by negative 2. And negative 2 is, of course, a negative number. And in inequalities, when you divide by a negative number, you have to reverse the sign. So what does this mean? In this case, it means that x becomes smaller than negative 1. So the larger turns into the smaller. And if it would be larger or equal to, it would turn into smaller or equal to. Yup. That's what happens when you divide by a negative number. When multiplying by a negative number, that does not happen. And let's actually have a look at whether I did not lie to you. Let's just substitute. So if this inequality is solved correctly, then theoretically x can be equal to, let's put an equal and a question mark, to negative 2, if I solve the inequality correctly. So how do we check this? Let's substitute x equal negative 2 into here, into the second step over here. So we get 4 is larger than 2. 4 is in fact larger than 2, therefore we solved it correctly. And that is pretty much how you would prove it. Okay. Let's have a look at one that's slightly more complex. X divided by -2 plus 2 is larger than 2x. This is slightly more complex. This is getting to maybe 2 or 3 mark questions. Now, the first step, you can really do either. You can either multiply by -2 or you can carry the 2. Personally, I prefer multiplying by the -2, so why not do that? So x is equal to plus 2 times -2 is just -4, which is larger than -2 times 2 is -4, -4x. Then we carry, or we just add -4x to both sides. We get 5x is larger than, and we carry the -4 to the right, larger than 4. Therefore, x must be larger than 4/5. Well, therefore, x must be larger than 0.8. Now, once again, let's check this. Let's check if this works. So if this is correct, then x can be equal to 1, because 1 is larger than 0.8. So let's check this. 1 divided by -2 is -0.5. Let's do that. 1 divided by -2 is 0.5. 0.5, -0.5, sorry. -0.5 plus 2 is plus 1.5. 2 times 1 is 2. So 2.5 is larger than 2. That is a correct statement. Therefore, this, well, in one case, is correct. And in our case, because we showed clear algebraic working, in our case, one case is just enough to prove our solution correct. Okay. So let's outline the key points to remember when solving linear inequalities. So first of all, it has to be the first point that I mentioned, and that is that they are solved almost exactly like linear inequalities. So one, solve like equalities. Point 2, when dividing by a negative number, reverse the sign. This is the most important thing, and the GCSE, they love to catch you out on this one. They just love it. You'll see past papers where this is happening so many times, and you will see examiners' reports, and in the examiners' reports, the examiners will write that, well, yes, and many students got caught out on this rule because tra-la-la-la-la. And so you must remember this for the exam. Okay, now as any inequality, or just as anything in math, really, you can write it down as a function. And functions is a really good video that we posted yesterday, so please have a look at it. I will add the link in the description. So f from x can be written down as, let's go 2x plus 1, the exact example that I used in the video. So, of course, now we can just write down f of x is larger or equal to 1. And we will be asked to solve this inequality. So how do we solve it? Well, we just say that 2x plus 1 is larger or equal to 1. We carry the, we subtract 1 from both sides. We get 2x is larger or equal to 0. Therefore, x must be larger or equal to 0. Done. Okay, now another thing that we might be asked is we might be asked to draw this inequality on a graph. Now this is where it gets a bit scary. And I will show you why. Okay, so what we would do is we would draw x. We would look at our final solution. Look at our final solution to the inequality. So we'd look at this. And we just say that x is equal to 0. We'll forget about this. just for now. And let's draw the graph f(x is equal to 0). Well, the graph x is equal to 0 is very simple. We just look at the x-axis, whereas x equal to 0, x is equal to 0 here, and this is literally just the graph of x equals 0. It is the y-axis. So where is x equal to 0 larger? Where is x larger than 0? Well, x is obviously larger than 0 over here, 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 here, over here, over here, etc., etc. So it's just gonna go over there. Just go speeding on right into infinity. And what they do in an exam is that they ask you to shade it in a specific region, and you literally just take your pencil and you would shade it all in. Nice. Now, we just had to look at a really simple example, but it does get harder with actually graphing them. And it gets harder when you get equations that aren't aligned but are diagonal. So let's have a look at how that looks like. So I actually should not have erased that, but okay. Let's draw another coordinate plane. And let's graph the following function. Let's graph the function 2x plus 1 is larger or equal to, oh, here, no, why not? Oh, sorry, is larger or equal to y. So x, 2x plus 1 is larger or equal to y. So therefore, y is smaller or equal to 2x plus 1. So we'll graph the function 2x plus 1. So 1 is the y-intercept, self-explanatory. Then it goes on a gradient of 2, on a gradient of 2, on a gradient of 2. Very nice. And we would simply draw function. Please don't give me a square root. Okay, there. Let's simply draw this function. Okay. Now we would look at where y is smaller or equal to this function. Now this is where the hard bit comes in, and this is where you have to remember our axes. So this is the y-axis, this is the x-axis. Now where is this axis smaller or equal to this graph? I mean, we should imagine that this graph stretches out over there, and of course stretches out over here. Now the answer is pretty hard, and this takes a lot of imagination, but it's actually everything that's below this graph. So when you would be shading it in, you would be shading in all of that, all of that, all of that, all of that, all of that. Everything below this graph would be shaded in. Okay, and of course if it would be larger or equal, then it would be everything shaded in over here. If it would be just larger, then you'd have to be very careful not to shade in the line. And if it would be smaller, then again you have to be very careful not to shade in the line and go this way. Yeah, that's pretty much it. If it would be equal, then there is no inequality, therefore we don't even need to write anything. Nice. Okay. Right, that's pretty much all of the theory for linear inequalities. And of course, I will end the video on this screen with this rule. So when you divide by a negative number, reverse the sign, please. Many students don't do it. Please do it, otherwise it's just messy, and don't be a disgrace. Okay, thank you for watching the video, and see you next time. Bye.